mechanism of dehydration of alcohol. It's also called acid catalyzed dehydration of alcohol. It's important from the point of examination. We know dehydration of alcohol takes place in presence of concentrated H2SO4. For example, it's a primary alcohol. What's the role of this concentrated H2SO4? It played two roles. One is it acts as a protonating agent. That means it donates proton during the reaction. And second, it also acts as dehydrating agent. So mechanism in all three steps. One is protonation of alcohol. Just I told function of H2SO4. It donates a proton. So protonation of alcohol. Second one, it is formation of carbocation. And third one, elimination of proton. We have three steps and generally it carries 3 parts. Even in SN1 and SN2 mechanism also, we can expect 2 or 3 parts. There also we have 2 steps in SN1 reaction, and in SN2 reaction we have 1 step. Well, here totally we have 3 steps. Well, the step 1 is protonation of alcohol. Protonation of alcohol. So I am writing the example directly. Alcohol as the ethyl alcohol. Formula for ethyl alcohol, we know CH3, CH2, then we have OH. It is ethanol or ethyl alcohol. You can write condensed formula also. It is not necessary to write like this only. So we have 2 lone pair of electron on oxygen plus proton, or it is H plus. So it is protonation. To give product CH3, CH2, then we have OH and H, then plus writing the positive charge on oxygen is important. Even in SN1 and SN2 also, writing the charge is important on specific atom. So here the positive charge is on oxygen atom. It is called protonated alcohol. Well, no need to write in the examination protonated alcohol. Simple. You have to show the formation of alcohol is ethanol. Formation of this protonated alcohol, but equation is sufficient. No need of writing protonated alcohol, etc. Step 2. Step 2. Formation of carbocation. Formation of carbocation. It's important. We know carbocation means the carbon carry positive charge is called carbocation. Here there is a loss of H2O. H2O get eliminated, and this positive charge is transferred to this carbon atom. So we have CH3, CH2 plus the carbocation is formed. Well, we have to write that protonated alcohol formula CH3, CH2, then we have O plus H and H. H2O get eliminated. It's a CH3, then we have CH2, then it's a plus charge on this carbon atom plus H2. So it is carbocation. Remember, writing the plus charge on carbon is important. So without this plus charge on carbon, you won't get a Mars because it's a carbocation. Usual students used to get confused for this plus and this plus. This plus is one more plus product it is. Here this plus means it is on the carbon, that charge is on carbon, so it is called carbocation. Step 3. Step 3. Elimination of proton. Proton eliminate from the adjacent carbon, that is from this carbon. Now you have to write, I am writing the complete formula of this CH3, CH2. We have positive charge here. Writing positive charge on carbon is important, without that you won't get a Mars. Elimination of hydrogen, that is proton H plus, takes place from the adjacent carbon. So H eliminate from here and you are getting the double bond between these two carbon atoms. So product is CH2 double bond CH2 then H plus. So ethene or alkene is formed. Step 1, protonation of alcohol. You are getting this proton from H2SO4 because we know H2SO4 is an acid, donate a proton. So protonation takes place. This hydrogen attached to this oxygen because we have one pair of electron on the oxygen. It accepts that proton and you are getting protonated alcohol. Second, there is a loss of H2O from the protonated alcohol to get the carbocation. And third one, elimination of proton. Proton get eliminated from the adjacent carbon and you are getting alkene or ethene. These are the 3 steps involved while writing mechanism, writing the charge and charge on specific atom, and also writing all the things. Even H plus also needed. Without this H plus you won't get a Mars, you are losing the Mars. So all each and everything you have to write for the mechanism. Well, after this you have to discuss on the oxidation property, oxidation of alcohol. So alcohol undergoes oxidation. So it depends on types of alcohol you are using. The product formed are different. Example, primary alcohol undergo oxidation to give aldehyde. Secondary alcohol undergo oxidation to give ketone. Tertiary alcohol undergo oxidation to give the carboxylic acid. Here, when the primary alcohol is heated with oxidizing agent, you are getting aldehyde. So aldehyde further undergo oxidation to give carboxylic acid. That means oxidation of aldehyde is more easy compared to that of the ketone and the carboxylic acid. So it undergo oxidation to give aldehyde, aldehyde further undergo oxidation to give the carboxylic acid. If you are using oxidizing agent like MnO4, HNO3, K2Cr27, etc. And in case of secondary alcohol, it do not easily undergo oxidation. You have to use little bit of powerful oxidizing agent like CrO3, chromium oxide or chromium sesqui oxide it is also called, or it's a chromic anhydride to give the ketone under a drastic condition, that is by heating to a long period to a high temperature with CrO3 or even by using some other oxidizing agent like MnO4. Under a drastic condition, that ketone further undergo oxidation to give carboxylic acid containing this number of carbon atoms. That means oxidation of secondary alcohol is difficult compared to primary alcohol. What about tertiary? Tertiary alcohol undergo oxidation only when heated with powerful oxidizing agent. Powerful oxidizing agent means like MnO4, but not with CrO3. It gives the ketone which further undergo oxidation to give the carboxylic acid. That means the oxidation is easy for the primary alcohol, then secondary alcohol, then tertiary alcohol. So, equation for the reaction of alcohol, oxidation reaction of alcohols. So, oxidation of alcohols. First one is primary alcohol, or I am writing A, primary alcohol. As I told, primary alcohol undergo oxidation with little bit strong, not powerful, strong oxidizing agent to give the aldehyde and then to the carboxylic acid. However, the oxidation of primary alcohol to aldehydic stage can be stopped by using mild oxidizing agent like PCC, that's pyridinium chlorochromate. Well, primary alcohol or 1 degree, we know it's also called 1 degree. 1 degree alcohol undergo oxidation with Cr27 bar H plus. That means Cr27 bar H plus, or even with other oxidizing agent to give aldehyde. It is further oxidized to carboxylic acid. It is further oxidized to carboxylic acid. Well, the formula for primary alcohol, we know CH2OH is the primary carbon or hydrogen or primary hydrogen. So it's RCH2OH. It undergo oxidation plus descent oxygen. The source for descent oxygen is Cr2O7 2 minus bar H plus means acid medium. The product is RCHO, aldehyde. Aldehyde is formed. So elimination of H2O takes place. I am writing minus H2O here. Aldehyde further undergo oxidation. It further undergo oxidation by same reagent. Because you are heating this mixture, immediately aldehyde is formed. It further is oxidized to carboxylic acid, RCOOH. But here there is no change in carbon number. Primary alcohol is oxidized to aldehyde, which contains equal number of carbon atom as in alcohol. It is oxidized to carboxylic acid. It contains same number of carbon atom as in aldehyde. That means there is no change in the carbon number in the product formed by oxidation of primary alcohol. But if you want to stop the reaction at aldehydic stage, then you have to use a mild oxidizing agent. Generally you are using PCC, that is pyridinium chlorochromate. Oxidation of primary alcohol can be stopped to aldehydic stage by using mild oxidizing agent, not powerful, mild oxidizing agent, pyridinium chlorochromate. So, it is I am writing here oxidation of 1 degree alcohol to aldehydic stage aldehydic stage can be stopped using mild oxidizing agent PCC. Its full form is pyridinium chlorochromate. Pyridinium chlorochromate. Its formula is C5N5H5 plus CrO3. This is the formula of pyridinium chlorochromate. So it's some mild oxidizing agent, not powerful as K2Cr27 or some other strong oxidizing agent. Well, equation is RCH2OH. It undergo oxidation by PCC, pyridinium chlorochromate. Product is RCHO and H2O. The example is CH3 CH2 CH2OH. We know it is called N-propyl alcohol. We can also name this one as propan 1R as per the IUPAC system. Propan 1R. It undergo oxidation by PCC, pyridinium chlorochromate. Product is CH3 CH2 CHO. The name of the product is methylprop, and we know suffix for aldehyde is R, so it is propanol. The name of this compound is propanol. One more example, it's a CH3 CH double bond CH CH2 OH. It undergo oxidation by PCC. Product is CH3 CH double bond CH, then it is CHO and H2O. Well, a question arises, how to name this compound? Already you have studied IUPAC nomenclature. If we have the double bond and OH group, then you have to number the carbon from the end which is close to the OH group or the functional group. 1, 2, 3, 4. We have a double bond is E and E. Total number of carbon atoms are 4. So distribute. Now on the second carbon we have En, then this is 1R. On the first carbon we have OH. Suppose there is no OH, simple if it is CH3, then we are calling that compound as but2ene, butene. Here instead of end E, you are writing R. So this is ON, alcohol. ON. OH means alcohol. It is on the first carbon. So it is but2ene, then 1R. Similarly, name of this compound is, common name is protonaldehyde. And IUPAC name is 1, 2, 3, 4. So it is but2en 1R. Simple but2nR is also called but2enol. That means on the second carbon we have a double bond. So this is oxidation of primary alcohol by using mild oxidizing agent. Second is for the secondary alcohol. After primary alcohol, we have secondary alcohol. As we know, secondary alcohol undergoes oxidation by using strong oxidizing agent like CrO3, also called chromic nitride, to give the ketone. Secondary alcohol, oxidation of secondary alcohol. Secondary alcohol undergoes oxidation. Secondary alcohol undergo oxidation. Undergo oxidation using oxidizing agent chromic nitride. Oxidizing agent chromic nitride. Chromic nitride. Remember the formula for chromic nitride, CrO3. To give ketone. As we know, ketone on reduction gives the secondary alcohol, aldehyde on reduction gives the primary alcohol. So the formula for secondary alcohol is RCHOH, R dash, which undergo oxidation by CrO3 to give R C double bond O, or simple we can write O plus H2. So this is ketone. It is 2-digit alcohol or secondary alcohol. Now the example for secondary alcohol, simple example is acetone CH3. Simple alcohol is isobutyl alcohol OHCH3, or it is propan-2-ol. Propan-2-ol is also called isopropyl alcohol. It undergo oxidation by CrO3. The product is CH3 C double bond O CH3. It's a ketone. This ketone is nothing but acetone, and IPSCA is called propanol. 3 carbon with propanol is replaced by ONA. Under drastic condition, it further oxidizes. Ketone is further oxidized to carboxylic acid. Under drastic means you have to heat to a long time, or heat to a high temperature, or by using powerful oxidizing agent. Secondary alcohol is first oxidized to ketone, then further undergo oxidation to give the carboxylic acid. Under drastic condition, secondary alcohol is oxidized to ketone and then to carboxylic acid. The formula for ketone we know. I am writing directly the example. Secondary alcohol CH3, CH2, CHOH, CH3. We know it is a butan-2-ol. It undergo oxidation by CrO3. So this on heating, you are getting CH3, CH2, C double bond O, CH3. Elimination of H2O takes place. So I am writing minus H2O. This further oxidized to carboxylic acid. Means let us heat it to a long period or long time. you are getting carboxylic acid which contains lesser number of carbon, CH3, CH2, COOH, CO2 and H2O. That means there is reduction in the carbon. Here we have 4 carbon, ketone is 4 carbon, but here we have only 3 carbon. The product is some propanoic acid because we have 3 carbon, so propanoic acid, and we have 4 carbon, so it is a butanol, ONE for the C double bond O, and oic acid for the COH. Totally 4 butanol, 3 carbon, so it is a propanoic acid. This is about secondary alcohol. What about this tertiary alcohol? Tertiary alcohol is not easy to oxidize, only under drastic condition by using its alkaline KMnO4. It is undergo oxidation to give the ketone which is further oxidized to carboxylic acid. So it is tertiary alcohol. Tertiary alcohol. So for the oxidation of tertiary alcohol undergo oxidation by powerful oxidizing agent. It is not easy to oxidize by powerful oxidizing agent like alkaline KMnO4 to give carboxylic acid containing less than, first it is oxidized to ketone, then to carboxylic acid which contains less number of hydrogen atom. Tertiary alcohol, I am writing 3-degree alcohol, undergo oxidation with powerful oxidizing agent or strong oxidizing agent, strong oxidizing agent to give strong oxidizing agent like alkaline KMnO4 to give ketone which is further oxidized to carboxylic acid. Formula for, I am writing directly the example instead of writing the general equation. You can understand more easily by writing the example. So example is CH3, CCH3, CH3, OH. This is tertiary alcohol. Tertiary alcohol undergo oxidation with powerful oxidizing agent. So here we need a strong oxidizing agent, alkaline KMnO4. I am writing MnO4 minus means permanganate ion in alkaline medium. It's a strong oxidizing agent. You are getting the product ketone. Ketone is the product. At first it is converted into alkene and then into the ketone. So I am writing directly the ketone CH3 C double bond O CH3. Actually, first elimination of H2O takes place to give alkene, and alkene is oxidized to the ketone. So ketone further undergo oxidation by using again MnO4 when it is heated to a long period or long time. The product is CH3 COOH CO2 and H2O. Well, in this case, say tertiary alcohol is converted into ketone. There is